Good afternoon. This course is on decision modeling, and this particular course on decision modeling will have these 4 modules, 2 weeks each. The first one is on decision analysis, the second one is weighting lines, the third one will be simulation, and the fourth one is on network models. As you have seen, the usual decision modeling course may also have topics ranging from linear programming to nonlinear programming, dynamic programming, so on so forth, and you will get so many courses already available on these topics. But in this particular program we have focused on these 4 specific topics: decision analysis, weighting lines, simulation, and network models, and so that people can also get acquainted to all these important topics as well. Now, who can attend this course? See, this course has a very wide audience who can attend this course, starting from the engineering students to management students to industrial engineering students, and as well as economics related students. Then let us go into the specific modules. The first module on decision analysis will first focus on the probabilistic concepts, and specifically highlighting the Bayes theorem. You see, usually what we find is that the a priori probabilities that we usually know as a part of probability concepts, they get modified to posterior probabilities when Bayes theorem is applied, and these become very important, particularly when we use decision situations and with experimentation. Say for example, you would like to find out the availability of a particular mining, maybe petroleum, let us say. So, the a priori probabilities may be something, and if you simply have to decide whether to dig for oil or not based on a priori probabilities only, you may be misled. Whereas, if you do a certain tests that whether oil is there or not, which we are calling an experimentation, the Bayes theorem can be applied, and you can really get the posterior probabilities from the a priori probabilities, and you can deal with the decision situations in a better manner. And all these things can be very nicely put in a form which is called decision tree, and that is a very important part of decision analysis. The second module for us is the weighting line models, and basically there are 4 very important topics which we should be discussing there, specifically on queuing models, the priority discipline queuing models, the finite population queuing models, as well as the queuing cost models. See, queues are formed everywhere, and specifically to see that the arrival rate and the service rate, when there is a lack of balance, then queues form, and these queues can, because the probabilistic nature of the both arrival and service, there are certain parameters like the waiting time in queue, the length of the system, and length of the queue, and all those things, they form a very important parameters to come up with system design challenges. So, all of these things we shall discuss in the weighting line models. The third most important topic for us is the simulation module. Both discrete event as well as continuous simulations will be dealt in this particular topic, and when it comes to discrete event simulation, specific focus on input modeling and output analysis both will be there. The continuous simulation where events do not occur, but the simulation is basically happening, the future events are functions of the past events, specifically those econometric models will be discussed. And one particular very important topic which is part of continuous simulation is system dynamics, where we specifically focus on the feedback loop systems, and specifically both positive as well as negative feedback loop systems, and how behavior is influenced by structure, that will be the focus of the simulation module. The fourth module for our decision modeling course will be the network models, and initially it will be started with introduction to graph theory, the general concepts of what is a graph and different kinds of graph that will be discussed, and specifically the tree and the spanning tree concept will be highlighted upon. Spanning trees are very important concepts, and essentially all optimal problem solutions are in the form of spanning trees. So, that will be highlighted, and two types of very important set of algorithms, the maximal flow algorithms and the shortest path algorithms, will thereafter be taken into. So, all these four modules will be substantiated by tutorials and specific assignment problems, and I hope this course will be of very high importance. Thank you very much.